today we are going to put it all together. And this is the chart that I'll be using, and this is on page 151. I will be giving you your own copy of this, and we are able to use this on the test. We just need to know how to use it. So it goes along with the little chart that we were using for vertical and horizontal asymptotes. We're still talking about the same n of x over d of x. All right, so let's put it all together. Section 2.7, graphs of rational functions. So we're going to work through it step by step. So example 2 is where I'm starting. We're going to sketch f of x equals 3 over x minus 2. And to help us with our sketch, we are going to use the chart that I just showed you on the other page. So if you want to have your book open to that would be great. So according to step 1, simplify if possible. And let's write, if you want, we'll do a little step 1, simplify, and we're going to put by factoring. So that's super important, by factoring. And when we look at our function here, 3 doesn't factor and x minus 2 doesn't factor. So check, we're done. Step 2, plot and find the y-intercept, if any, by evaluating f of 0. So they tell us what to do. So for step 2, we're going to do f of 0, which means we'll plug a 0 in for the x of our function, and we get negative 3/2. And step 2 said that was the y-intercept. So let's go right to the y-axis and put a point at negative 1.5, negative 3/2. Okay. Step 3. Find the zeros of the numerator, if any, by setting the numerator equal to 0. Then plot the x-intercepts. So we're going to set the numerator equal to 0, and these will be x-intercepts. So when we set our numerator equal to 0, there is no x. 3 doesn't equal 0, so that means no x-intercepts. Okie dokie. Now I'm going to erase this bit so I can stay on the same page. Step 4. Find the zeros of the denominator, if any, by setting the denominator equal to 0. Then sketch the vertical asymptotes using dashed vertical lines and plot the holes using open circles. Okay, so we're going to set the denominator equal to 0. We have no holes in the graph because nothing canceled out. But when we set our denominator equal to 0, we get x equals 2, and that's a vertical asymptote. So we will go to 2 on the x-axis and do a dashed line. That's x equals 2. Step 5. I just don't want to erase my function. Find and sketch any other asymptotes of the graph using dashed lines. Okay, so let's check out horizontal asymptotes, and you might look back at the little chart that we were using. We want to compare the degrees. Well, this is at x to the 0. So the n is 0, and the m is, I should be doing this in red. N is 0, and m is 1. So when you compare that, n is less than m, and that's choice A under horizontal asymptotes, which means y equals 0 is our horizontal asymptote. That's the same line as the x-axis. I want you to dot it right on the x-axis. I don't want it above it or below it. I want it right on the x-axis, and I'll be able to see it. It'll be just a little bit shiny or something. I'll be able to see it. Okay, and step 6 is a little bit of an odd step. Plot at least one point between and one point beyond each x-intercept and vertical asymptote. So what we are doing is we're looking to see what's crossing the x. The only thing I have on the x is this right here. That's the only thing that crosses the x. So that asymptote has divided my x-axis up into these two pieces. I want to test a point on the left of that asymptote and a point on the right of the asymptote. So the asymptote's at 2. On the left, 0 would be a great point to test. And on the right, 3 would be a great point to test. So we'll just plug 0 in to the function. And we already did that when we found our y-intercept. If x is 0, y was 3/2, negative 3/2. We already have a point there, actually. Plugging in 3 gives us 3 over 3 minus 2. It gives us 3 over 1, which is just 3. So we have the point 3, 3 that is on this graph. I wish I didn't have this purple all over my graph, but I can't erase it because it would erase everything. So all these asymptotes have split my graph into 1, 2, 3, 4 different quadrants. And we want to know where we're at as far as where the graph appears in these quadrants. So I have a point now in this third quadrant, and I just want to draw it so it hugs the asymptotes. And we have a point here in the fourth quadrant. There's my sketch. Now I'm going to plug it into the calculator and just see if I'm right. And if I'm not, I'm going to fix it a little bit. So it's not that you can't have a calculator, it's just we're trying to do it by hand to get some idea of what's going on, to make some big connections. This last one, I skipped it, but it just says use smooth curves to complete the graph, which is what we did. Okay, let's do another. Let's do example 6. F of x equals x squared minus x minus 2 over x minus 1. So we're going to do a big sketch using the steps. The first step says simplify if possible by factoring. And the numerator does factor x minus 2x plus 1 over x minus 1. And nothing cancels out. So that's our factored function. Step 2 says find the y-intercept by doing f of 0. So you could just imagine putting zeros in for all these x's and seeing what's left. Negative 2 over negative 1, which is positive 2. That's our y-intercept. So go straight to your graph and graph that y-intercept at 2. Let me actually get rid of that. Step 3, find the zeros of the denominator. Oh, I think 3 is the zeros of the numerator. I'm using the factored form. So x equals 2 and x equals negative 1. And it says these are x-intercepts. So go to your x-intercept, x-axis, and put a point at 2 and a point at negative 1. Step 4 was find the zeros of the denominator. And it said these are the vertical asymptotes. So go to 1 on the x, and whoops, I want to do red. Do your dotted dashed line for your asymptote. Step 5 is find any other asymptotes. So when we compare our degrees, we have a 2 and a 1. And n is greater than m. N is always the degree of the numerator. So n and n. N for numerator. So n's the degree of the numerator. So 2 is greater. So step C said, if n's greater than m, there is no horizontal asymptote. But we need to write in, but if it is greater, so please write this in on C of, let me show you what I'm talking about. On that chart from the other day, so we got n to be greater than m. So there is no horizontal, but we need to say, but if n is greater than m by exactly 1, there is a slant asymptote. I ran out of room. That we find with long division. Okay. So our n is greater than m, and it is by exactly 1. 2 is greater than 1 by exactly 1. So we have a slant asymptote that we need to find with long division. So I'm going to erase this bit so we can stay on the same screen. And we'll set up our long division. Doesn't look like anybody's missing, so we're ready to just divide. X times x is x squared. So we distribute, change signs, gone and gone. So you bring down your next thing, and we can't multiply x by anything to get a constant. This is our remainder. And this is the equation of our slant asymptote. It's just y equals x. So for step 5, I would say I have a slant asymptote at y equals x. You probably remember how to graph that using y equals mx plus b. If y equals x, then that means m is 1, and you're really adding nothing as your y-intercept. So we'll start out at 0, and these aren't points, these are like dashed asymptotes. So we'd start out at 0, and we'd rise 1, run 1, rise 1, run 1, rise 1, run 1. And we can go down 1, left 1. And so we will just dash that line through that little bit of a graph that I was trying to make. And that's our slant asymptote. So the slant asymptote divided the graph up into sections with the vertical. You've got this section, this little section, this section, and this section. So we have 4 sections. We'd like to know what region our graph is going to appear in. So we will do step 6, where we test some points. And we're going to look to see what all intercepts the x-axis. So I've got an x-intercept, so I wonder what's going on over here to the left of that. Between the x-intercept and the asymptote, and between these asymptotes, and between the asymptote and the x, and on this side of the x. So everything that crosses the x splits us up into regions. So we have one region, a little bitty area, an area, an area, an area. And we would like to check x's in each of those regions. So let me get rid of all that. So we're going to test -2. We're going to test -1/2. And we're going to test +1/2. and positive 3/2, and 3. That's going to give me an x value in each of those regions. Now this could be a little tedious, but we are going to want to plug this into our calculator anyways to see if our graph is similar to what they got. So let's go ahead and plug it in right now. And we're going to look at our table for these. But if we're counting by ones in our table, then these fraction values are not going to show up. So I can't remember if we've done this or not, but I'm going to try to show you this. I don't know if it's going to work or not. So I've got a graphing calculator here. So hopefully this will record. I'm going to put my function into y equals, which I'm not really going to do. I'm going to put my function into y equals, and I'll go second table set, and I'm going to go down here to independent, which is the x variable, and I'm going to move over to ask and hit enter. So then I'll go to second table, and it's ready for me to ask it which x values I want. And sorry about moving while doing this. I can't remember the x's that I put down, but I feel like it was like -3, -1/2, +1/2. Sorry, I'm shaking. I think we did 3/2, which is 1.5, or I can do 3/2. And I think I did 3. Whatever those values were that we wrote down on the table. Now I've got, let me just get rid of y2. Okay. So now I've just got, as soon as I tell it what the x is, it's going to tell me what the y is. So I can just write these down. If that didn't work, you'll have to tell me later because you just heard it verbally. All right, I'll take a picture of it. We'll see what happens there. We wanted to test those values. Looks like my memory wasn't so great. I actually wanted -2 and not -3, so I'm just going to fix that. So -2 is 3.5. -1/2 is 11. +1/2 is -9. 3/2 is -2.3. And 3 is -0.67. Now that's just kind of rough and estimated, but it's going to give me points in each of these regions, so it helps me to make my graph. So -2 is at 3.5, which would be about right there. -1/2 is at 11, so way up here. I didn't graph that quite right. +1/2 is at -9, so way down here. 3/2 is at -2.3, and 3 is at -0.67. 3 is at -0.67. Oh, none of my values are right because I didn't change my function in my calculator. I'll pause the video and get it fixed. Okay, I've got the right function in now, so I see the right table. So -2 is at -1.3. That looks better. It's hugging the asymptote more. -1/2 is at 0.83. +1/2 is at 4.5. +1/2 is at -2.5, and +3 is at 2. And this makes us feel very confident to know that we can sketch our curve like that and then compare it with the calculator. Alrighty. I think you're ready to try a few of these. Good luck, and I'll see you on Wednesday.